Haha. Okay. So we have 3x equals 60 and then x equals 20. So 20 degrees is the smallest angle.
So, okay, they aren't asking you to find like the value of D, right?
No, I didn't need this at all.
Okay, cool.
All right.
So this was number 10 on page 2. Again, so we knew that all of the angles added up is going to equal 360. And since we're using all the angles of an arithmetic, we used the sum of an arithmetic sequence formula, and we just plugged everything in. Okay, next question. Y'all, I'm not going to lie to you. I took a nap because the faculty meeting went long, and then I ate my lunch and took a nap, and I fell asleep, and my alarm went off probably 3 minutes after I fell asleep. I'm really mad about it.
That's not very enjoyable.
It's not. Anyways, sorry. I just wanted to keep you all posted on my life since I know
More sleep than I get.
all right, so next question. Sorry.
Hold on.
Y'all asked about number 9 and 10 on the end of Unit 7 problems, I'm pretty sure. Or was that on the end of the mixed problems?
No idea.
The last time I asked you was the number 10 of this page of the Unit 7 problems.
Okay. So an infinite geometric series is given by this formula. Find the value of x for which the series has a finite sum.
Which one are we on?
Number 10 on the last page of Unit 7 problems.
Gotcha.
An infinite geometric series given by.
I just
Find the values of x where it has a finite sum.
How many questions are on the test tomorrow?
I think it's like 70 marks or something like that.
Oh,
What?
It might be closer to 90. I can look it up real quick.
how's the curve on this one, Miss Thompson?
What curve?
Wow, that
I'll
is
see.
How's oh my gosh. Miss Thompson, I got 100 on one of the tests that you just put in, and my grade only went up 1 point. It's
Because your test grades aren't that bad.
But then why do I have an 87? I failed 2 of my tests.
Right, and you haven't done corrections on them.
Well, because I don't have my actual tests at school.
No, I sent you some of them, and then you say, Miss Thompson, can I have these tests? Novel concept, I know. 10, 20, 30, 40, 47, 54, 61, 71, 77, 84 marks tomorrow. So I'll give you the full 90 minutes, which is only 6 minutes extra. And again, just like last time, I'm not expecting you all to finish every question even, but we still have to push you to get to the point of where you'd be at the IB exams.
Okay.
If we have questions left on the free response and we put like random stuff down, like just random formula, do we still get points, or is it just like?
It depends on the question. Sometimes you get marks for method, meaning you wrote down the formula and plugged stuff in. Sometimes you can set up the wrong, like you can use the right formula, but you'll use the wrong number. You lose that mark, but then you get marks after that for continuing with your answer. Like, I mean, it really varies from question to question.
Okay.
All right.
I wish there was a set answer for me to give you, but like in terms of timing, my recommendation is always to do the questions you know you can do first, to then go back and work on what you can, and then with your like ending time, if there's questions, like throwing down formulas and just trying to get any amount of points you can on any question. Okay.
All right.
Sorry, Knock, I keep on getting distracted. I promise I heard you ask the question.
No.
Okay, so we're trying to find the values of x where it has a finite sum. So this is
Does that mean not
Two.
infinite?
2 times 4 minus 3x to the k power. And it's a sum where k equals 1 to infinity. So if you were to use, so this is an infinite geometric series, so you need to use the infinite series formula, which is the infinite sum formula, which is u1 over 1 minus r. Okay, so in this case, our u1 is where we plug in 1 for k. So that would be 2 times 4 minus 3x to the k power. And then we divide it by 1 minus r. And our r is whatever we're multiplying by each time, which in this case is 4 minus 3x.
I thought you said the k was 1.
So then we can cancel those two?
Sorry, k is 1, you're right, which is just 1 up here.
Oh, okay.
You can't just cancel things, but I am going to try to simplify this as much as possible. So we get 8 minus 3x.
Wouldn't it be 8 minus 6x?
Oh my goodness. And then negative 3 plus 3x. And then I think I'm seeing.
Cancel it, right? Because it's subtracting to the 1.
What?
You can't cancel the 4 minus 3x.
Right.
Okay.
Let's see, that would be negative 1 plus x. So that won't cancel anywhere. So then it wants to figure out, it says the values of x where the series has a finite sum, meaning that this would be
Would you set it equal to the regular formula?
That's what I'm thinking, since that's finite. Where they would, I think it's where they would be matching, yes. So the regular sum formula for geometric is u1
1 minus r to the n over 1 minus r.
So u1 we have is 2 times 4 minus 3x to the first power. That's our u1 times r to the n, which is 4 minus 3x divided by 4 minus 3x minus 1. Whew.
Wouldn't it be 1 minus 4 minus 3x? Like 1 minus that whole thing?
If I did that, then I would have to do, I can do that, but this is actually minus 1 up here. It's this.
Oh, like that way. Oh, you did it that way. Okay.
I did that one. But if I do it the other way, actually, then my denominators are the same. So I can cancel them. So I'll do that.
I'm confused.
I'm using the second finite formula.
I didn't even know there was a finite formula. Second time. So it's not the regular one?
I mean, it is. There's 2 of them. They're just written differently.
Okay, y minus 14.
That's a parentheses.
Oh, yeah.
Okay, so our denominators cancel. Just doesn't feel right, but whatever. Okay, 8 minus 6x is equal to 8 minus 6x times -3. Actually, I'm gonna do the,
The other way.
no, I'm just gonna leave this for now.
Okay.
Okay, because these can turn, you can divide by 8 minus 6x on each side, and you end up with 1 equals. Do y'all have that written down from there?
Mm-hmm.
No, hold on.
Okay, I'm gonna start erasing the top. I'm gonna continue to solve the equation. So I have 0 equals.
I have a question, Ms. Thompson.
I'm listening.
Okay. Where did the negative sign go after the comma?
When you divide 0 by a negative, it's
Oh.
just.
You just divided. Okay, I got it. Cool.
Okay, so my dilemma here is I know that we're solving for x, but I've ended up with 2 variables within.
Mhm.
So I'm trying to reread the question. Find the values. I could try taking the log of both sides. This just seems,
And that's too much.
yes.
So do you just not supposed to set it equal to?
That's what I'm wondering. Okay, I put a star next to it. I'm gonna keep thinking on it while y'all look for your next problem that you want to look at.
Can we do number 8 on that page? I think. Wait, did we do that?
No, we didn't.
We didn't, right?
Yeah.
Can we do number 8 on that same page?
Yes. Okay, I got it, I think. I think here, I think your R, never mind. No, I'll look at it again. Okay, number 8 on the same page. Gosh. All right, consider the infinite geometric series. For what value does the series converge? So what does converge mean?
Come together.
Yeah. So when a series converges, so the convergence test is where let me find so the first thing you're going to come up with is your sum formula. So if you were to write this in terms of sigma, this would be 2x over 3 to the nth power, where the first n is 0.
Mhm.
And then this is infinity. Does that make sense to everyone so far?
No.
No. Why not?
Why are you? Oh,
Wait, are we on 8 or 10? I'm kind of confused.
8.
8.
And we're writing it as like,
Well, because it says it's an infinite geometric sequence.
okay, but I don't know. Okay, keep going.
Is everybody okay?
Yes.
Yeah.
Okay, so once you have this, when we say convergence, I'm trying to figure out I'm trying to find the IB version of the formula. Hold on. So for convergence, basically what you're multiplying by each time, it has to be between -1 and 1. Your R. And what's our R in this case is 2x over 3.
Can you explain why it has to be between -1 and 1 again?
It's just the rule.
Okay.
If your denominator of your fraction, you know how with the sum formula you have the 1 minus r on the bottom,
Yeah.
or the 1 plus r.
Yeah.
So depending on those two formulas, you don't want it to be, you can't have it be 0, and you don't want it to be like yeah.
Okay, I got it. Uh-huh.
It has to be smaller than 1, or it can't be greater than 1 or
It has to-
greater than -1, because then the fraction diverges.
Okay, makes sense.
Okay. So here you just solve both of these. So you would solve -1 less than or equal to 2x over 3 and 2x over 3 less than or equal to 1. And you solve them both the same way. Which I think that's what I was looking at on the last one, and I think your R just has to be less than 1.
Yeah, I did it, and
You did it where R is less than 1 on the last question?
yeah, so use the absolute value and everything.
Yeah, so it would be this. That. For number 10. Sorry. I know I just jumped. Just by the same principle, is you just need it to converge.
Mhm.
But I'm going to double check right now, but I don't think there's a convergence question on the test.
Oh, so this type problem won't even be on it.
I don't think so. I'm checking right now. Y'all can start looking for your next question though.
Is number 10, a question like number 10 going to be on the test?
That's the same type of convergence question.
Oh.
Okay. So we won't have sigma notation on the test tomorrow.
That's
No.
not what I said.
Okay.
We'll have sigma notation, we just won't have convergence.
Okay.
Put number 8 up at some point again.
Yes. That one, I think. Yeah.
And x has to be no, like different than 0, right? Because
in-
r needs to be different than 0.
R could be 0. It can't be 1 or -1.
Oh.
Which is why these are not equal. Less than or equal to signs. They're just less than signs.
Thank you.
Okay. Let me see if I can find one that's like one of these. Questions like 6 and 7, they're not even necessarily exactly like 6 and 7, but those sorts of word problems where they give you like not the exact same thing that you need. Does that, like, it gives you information other than R and you have to like work backwards to find stuff.
Ooh.
Wait, like number 6 on the last page?
Yes.
A geometric sequence of all positive terms.
Yes.
Can we do that one then?
Sure. Sorry, Isabella's mom sent out an email. I got distracted again.
Oh, no.
Surprise, surprise. Ms. Thompson's distracted. Okay, a geometric sequence that has all positive terms. The sum of the first terms is 15. So U1, oops, where's my pen?
What number is this?
Number 6.
The last page of the unit 7 problem.
And then the sum to infinity equals 27. So they want us to find the common ratio and the first term. Okay, so we can rewrite this one. Let me change colors actually. I'm going to rework this part of the problem first. So remember, since this is geometric, how could I rewrite U2?
U1 plus
Plus U1R. Is that it?
Yes.
Uh,
Does everybody understand why? Let me rephrase the question. Does anybody not understand why? Okay, wonderful.
slightly confused.
You're confused?
Slightly.
Okay, so I'm going to do this with just numbers for an example, real quick. If I have it says the first two numbers in a geometric sequence. So let's say it's 2 and 6. Those are our first two numbers. What am I multiplying by each time, Leonard?
3.
Okay, so I'm multiplying by 3 each time. So this could be rewritten as 2 times 3, right? What would the next number in the sequence be?
18.
Which could be rewritten as 2. Sorry,
Times
let me.
9.
I'm gonna do 6 times. Right, because it's the thing before it, which is also the same thing as. Goodness, my eraser. 2 times 3 times 3, right?
Right.
Does that make sense? Which is the same thing as 2 times 3 squared. And all of these 3's are just the different versions of r. So that's how we got the first term times the common ratio, just like 2 times 3.
Okay.
Okay, so this is equal to 15. Everybody okay with that so far? Maybe.
Yes.
Okay. Also knowing that the sum of the first two, we also have a sum. That's when we know exactly how many things we're adding. That's called the finite sum. So we have a formula for the finite sum. So this whole thing is also equal to u1 times r to the n. So how many terms did we have? Two terms.
2 terms.
Sorry, my mic is muted.
Okay. So here we have 2 equations. Let's do, I'm going to do u1 times 1 plus r equals 15, so that I can say u1 equals 15 divided by 1 plus r. Okay.
Mhm.
I'm going to plug in this u1 for this u1 here. And I end up getting 15 is equal to 15 divided by 1 plus r times r squared minus 1 times divided by r minus 1.
I have a question.
What? I might end up with what I just did. Dang it.
Oh, it's like, I don't know if it's like, can you do the geometric sequence the other way too, where it's like 1 minus r to the n, or do you have to like only do it this way?
No, you can do it the other way too.
Okay.
I actually am gonna backtrack again, guys. I'm sorry, but I just ended up, I can walk through it if you want to see what happened to me, but I'm gonna end up with just like it's just gonna be 1 equals 1.
Oh.
So I'm gonna backtrack a little bit. And I'm actually gonna try to use the geometric series instead. Well, I do have, sorry, real quick. U1, we did solve that. U1 is equal to 15 divided by 1 plus r. I'm gonna keep that, sorry. I'm gonna try to work with this formula now, which says that 27 is equal to What's
U1
the
over
infinite formula? U1
U1
over 1 minus R.
You
Yeah.
want everyone minus R.
Okay, and now I'm going to plug this in for U1. So I would
Okay.
end up with 27 is equal to 15 divided by 1 plus R divided by 1 minus R, which can be rewritten as 27 minus 27R is equal to 15 divided by 1 plus R. Okay, and then that's gross.
Do you multiply 1 plus R?
Yeah, so we have 27 minus 27R minus 26R plus R squared minus R squared.
I got. Oh, did I do? I got 27 minus 27R plus 27R minus 27R squared.
So that. I want a bigger iPad.
Wait, no. I got 27.
27. I'm going to just write out all the steps. Forget this. Okay, minus 27R plus 27R minus 27R squared.
Yeah.
That
Mhm.
is equal to 15. I'm going to erase a little bit at the top, maybe. If that's okay by everyone. And we end up with 12 minus 27R squared equals 0. 12 is equal to 27R squared. 12 divided by 27 equals R squared. So R is equal to the square root of 12 over 27.
is-
And
2/3.
sure.
I'll just put it in my calculator. Wait, R is equal to 2/3.
Yeah.
Like, yeah. Like after you do that.
I was like, wait a minute, that's not right.
What?
Okay, sorry, here. Let me simplify the fraction first.
Yeah.
This fraction is the same thing as 4. Gosh. You divide everything by 3 and you get 4 over 9. When you take the square root, you get 2/3 plus or minus. But I think you only need the positive R in this case. Because the sum of the two numbers is positive, that means that R has to be positive. Now that we have R is 2/3, we can plug back R into our U1 formula. And we get 15 divided by 5/3, which is 9, right?
Yeah, it's 9. So to solve that kind of problem where it's like a geometric, they give you all that, you just have to set it equal to the infinite sum formula.
Yes, I mean, because they gave you the part of infinity. And that's what I was saying. It's not even exactly that. I'm just saying the things where you have to like use system of equations, basically.
Mhm.
Solve for one to plug into another. 7 is similar. Do y'all want to try that?
Yeah.
Miss Thompson.
Yes.
So we all know that the sum to infinity is U1 over 1 minus R, right?
Uh-huh.
So can I put it in the equation like for the finite sum? It is u1 times 1 minus r to the n over 1 minus r. So like we can factor how do I say it? Like I don't know how to say it, but like you can take u1 and over u1 over 1 over r separate out and then take 1 minus r to the n separate, like do you know what I mean? Like I
Not
hope
exactly. Are you saying like to turn 1 minus r to the negative first power?
so what I'm trying to do here is like put the infinite sum into the finite sum formula.
That's what we did right here. Is that what you're saying?
Kinda like can I write it down? Like can
Yeah. You can annotate on the screen, I think.
Okay.
While y'all are waiting, go ahead and try number 7 on your own, and then we'll go through it to check everybody in case you get stuck. Not a chance, Jacqueline. Okay, yes, I'm following you a little bit more. Now you're saying, can you plug 27 back into the other sum formula?
Yes.
Yes, you can.
Okay. Thank you.
I think that's I think you can do it. I think it's a slightly more complicated way to do it. In terms of, I think your way could be considered easier if that were the only thing you were being asked to do. Like conceptually, the system of equations thing is the thing to practice, but if you feel confident with that, then yes, you can do this way. You should get the same answer.
Thank you.
Uh-huh.
Are we doing the like by ourselves and then together?
Yes. Is anybody just totally stuck and doesn't even know where to start with number 7?
Just working.
I just have a question about this one.
What's up?
So when it says the sum of the first 4 numbers is 30, does that mean that u1 plus u1r plus u12r plus u13r is equal to 30?
Wait, say that one more time.
u1 plus u1r plus u12r.
Not
plus
2r, r squared.
Oh, r squared and then r cubed.
Mm-hmm.
Oh, that makes it so much harder.
Actually, Knox Way might work really well for this next question. But if you've already started, go ahead, try it. I'm gonna do it the way I've been doing it. Let me just stay consistent.
Okay, got an answer. Took me a while.
Okay. I'm kind of stuck on this one.
Not sure if it's the right one though.
Leonard, did you get 0.125?
I got 1/4.
I got
Oh.
0.125.
Okay.
I got 1/4.
You probably dropped a 1 then somewhere, Leonard, possibly. Like one of the minus ones or something like that in one of the formulas.
Oh. Did I? Just-
Oh my gosh.
What?
I made a mistake.
Uh-oh.
Wait, why?
I tried to factor out. I think I made a mistake. What if I just erased all? I'll be mad.
Yeah, like, wait, wouldn't you do that? But then to find 8, you just plug in R8 minus 1. Like, the change of the n.
I did have it right. Dang it. Okay. I remember that part of the answer then. Is that what you got for your R?
For my R, I got half.
Like exactly 1/2?
Yes.
Okay, I keep on getting 0.585, so I'm messing up.
Yeah, me too.
That's what I got too.
Oh. Okay.
Can I send you my work via Remind so you can?
Sure. I can. I mean, you can. I just. I think that's right. Like, I don't know. Did you send it, Sonia?
Remind's not working, so it's sent via email.
Okay.
Did you get it?
I did just now.
Okay, good.
Oh my gosh. All right, everybody ready to make fun of Miss Thompson? I just said that 32 divided by 2 is 17.
That's not terrible, Miss Thompson.
Oh, wow, you're so nice to me.
You can't ever go over my head again, Miss Thompson. I don't want to hear it ever again.
Rohan,
I
you've done
told
so
you
much
that we're
worse.
one and the
Shush.
same, Rohan. I don't know what you're talking about.
Rohan, you've done
Never.
so much worse. Just shush.
Never am I going to hear this. I just never want to hear it again.
Miss Thompson, I'm sure you're gonna laugh at me because I made a mistake in my my work yesterday. So you're fine.
Okay. Okay, but this is I got it now. We're here. We made it. Jesus. Okay, so I don't know if anybody's been following what I'm doing on the screen, but I'm gonna talk through it out loud. The first thing we're gonna look at is the solving for U1 up at the very top in blue. Do y'all see that? Does anybody have any questions about that?
I do. I kind of showed up a little late. I'm sorry.
That's okay. So what I did is I multiplied by 1 minus r on both sides. And I personally saw that this right here was r minus 1. So I wanted to turn my 1 minus r into an r minus 1. And the way you do that is you factor out a negative 1. And so that's why the 32 became negative.
How do you? Okay. So the negative.
Like if you were to
why-
multiply r minus 1 times negative 1.
Oh, because it just flips everything. Okay.
Okay, so everybody's okay with just solving for that? Okay, so once I solved for my u1, the next thing I did was I plugged it into our finite sum formula. And then when you do math correctly, r minus 1s, they cancel. And you get 30 divided by negative 32, which would be negative 15 over 16, not 17. And then you add this 1 to both sides, which gets you to the 1/16. So that's where you get r to the 4th equals 1/16. And then you take the 4th root, and that's how you get r is equal to 1/2. After that, we can solve for the finite sum of 8 terms by plugging everything back in. So you plug in your 1/2 for all of your r's. And after you do that, you do, the question says to subtract this difference from the infinite sum. So you get 32 minus this answer, which when you plug in 1/2, you get 30.75, right? Somebody who actually got the answer. I haven't plugged in.
What were you asking for?
Well, we can still cancel those. When you plug in 1/2 to the 8th power, so 0.5 carry 8, oh my gosh, 0.5 carry 8, minus 1 times negative 32, and you get 31.875, right?
Yes.
And then you do 32 minus that, and you end up with 0.125, and that's your final answer.
Is there going to be a problem like that on the test?
I mean, I'm trying not to tell you guys what's on the test, because if I continue to tell you what's on the test, it doesn't help you at all, really. It helps you immediately, but not long term. There are questions. There's one similar to this. There is honestly one question on the test that I left on there because I think you will all skip it. I want that to be the last question you come back to try to solve for. It's definitely solvable, but I think that looking at it, like even me as a teacher, when I look at this problem on the test, I can give you the hint that it involves natural logs.
Oh
boy.
And me as a person, when I see natural logs, I don't want to do it.
Me
Right.
either.
So like, that's what I'm talking about, is like, there are factors of some of this exam prep where I want to see how you all do. There's already so many curves in place, but I don't want to give you guys a test where you exactly know how to do every single problem, because that is not going to help you on your IB exam. Does that make sense?
Yeah.
Mhm.
Like, so hear me say that I recognize that we're not doing a problem like every problem on the test.
Mhm.
And that's okay. There is one with a lot of words where it gives you like the first term of an arithmetic sequence and the first term of a geometric sequence, and then it wants to know where they intersect again if the 12th term is this. Like, it's along the same nature, but that one doesn't involve infinite sums,
Okay.
if that makes you feel better.
Ms. Thompson, I have a question.
What's your question?
How did you go from 30 equals negative 32 r minus like all of that to the r equals the 4th root of 1 over 16?
So we canceled the r minus 1s. That's in
Okay.
green.
I saw that.
You divide 30 by negative 32, and that gets you this negative 15/16.
Oh, okay.
And then you add this 1 to both sides. And that gets you this.
Oh.
And then that simplifies. Okay. The things with you remember the questions with the page numbers?
Yeah, can we, yeah.
You want to see one like that?
Yeah.
Okay.
Page numbers?
It was on our last test too.
Yeah.
Oh.
Number 19.
Which there was one like that on the packet too, right? Like I took it from the packet and just changed the numbers because we
Yeah.
went over it in class. Number 8 on the first page.
Machine theorem problems?
We did that one multiple times.
Right.
Let me see if I can. I'm trying to read these questions without giving away. Okay, what if I gave you a picture? Okay, and it has this. This is your picture. And part A, I want to know how many bricks are on the nth row. How would you guys do that?
Wait, can you repeat the question?
So if I want to know how many bricks are on the nth row, meaning I basically when it gives you a variable, that means it wants you to come up with an equation. So what would be the equation to figure out how many bricks are on any given row?
You'd use the arithmetic sum sequence, or not the arithmetic sequence formula.
Geometric sequence.
Why is it geometric, Knock?
Because it is the power of 2.
Yes. So our formula would be what?
It will be UN equal 1 times 2 to the power of n minus 1.
Perfect. Does everybody understand that?
Yeah.
That's the first problem. Okay, what if I said, hang on. That 31 bricks are used. And I want to know how many rows are there?
Oh, like in total there's been 31 bricks?
Yes.
So then would you do 31 is equal to UN 1 minus RN over 1R?
Yeah. Right?
Yeah.
What's my U1?
1. Oh, is this when you have to take a natural log?
No.
You don't have to take a log on this one? Like, don't you have to try to find end?
You will. I would use my calculator on this one.
Okay.
Yes, you could totally take the natural log and try to solve it that way. I would use my calculator.
Okay.
I would type into my calculator 31 minus x equals, or wait, we know what our common ratio is. Jeez.
Yeah, we know wait, wouldn't it be r minus 1 instead of 1 minus r?
Yeah, I would.
Okay, so this is 2, and then 2 minus 1, you said?
Yeah. Wait, if somebody can check me on that.
I
No,
think
that's
you're right.
Okay.
So what I would type into my calculator is 31 equals y1, and then y2 equals 2 to the n minus 1. And then I'd find where they intersect.
Do you not have to take the denominator into account?
It's 1. 2 divided by 2 minus 1 is 1.
That's
Wait, so like hypothetically, let's just say that you had to do the log. How would you do it? Because I kind of forgot how to do logs.
I still don't know that. I think I see them. I don't know how else to. Okay, you would end up with I'm going to use change of base instead of using logs. So how can I rewrite 32 as 2 to a power?
2 to the power of 2 to the power of 5.
That's what I would do.
Wait, say that again?
Oh yeah, that's what I did because I had 32 is equal to 2n and then okay.
Could you say that again?
I used change of base. So I rewrote 32 with a base of 2.
Okay.
So how do you rewrite 32 with a base of 2?
So that's 2 to the that's 2 to the 5th. Okay.
And then n equals 5. So there's 5 rows.
That's an easy question.
Okay, and then what about this one? Okay, wait, I have to keep reading this. Okay, if I'm building a large, like I'm still building the same tower, and the largest pyramid, let's say my the total number of bricks is 2 times the number of bricks wait. This is so much harder to do on the spot. In the last row. I'm just going to put it that way.
Oh, that's a hard one.
So I'm just going to walk you through how to do it. This is probably not perfect because I made this number up right here. But what you would do, so since I said the total number of bricks, you would use your sum formula.
Mm-hmm.
And then the number of bricks in the last row, we came up with that formula right here.
UN, okay.
And so if I said 2 times, then the sum would be equal to 2 times 1 times 2 to the n minus 1. And then you would just solve the equation like normal.
Oh, that's easy.
Like it sounds like when you phrase the question, it seems really complicated. Other times it's not. Does that make sense?
Mhm.
Okay.
you
Let me keep
minus
looking at the test.
N minus 1. Okay, I got it.
Could you give us a version of the really super duper hard question that's supposed to confuse us, but like not give us that question, but like something
I
similar?
don't honestly know if I can.
Darn. Is there any way for us to prepare for that question?
Full send.
How's the test curve?
It'll depend on how y'all all do. And I don't normally curve a lot. The last one got a big one, or a relatively big one. But the curve is always based off of how y'all perform.
Everybody fail.
No, that won't help.
Believe me, I know.
So the curve is not based off of how everyone does. The curve is based off of the lowest performing student. So basically what you really need to be asking is for one person to bomb it.
I got y'all.
Come on.
But
Okay.
even that doesn't work out perfectly. It's still skewed. But anyway, okay, I'm reading. Let me see. Okay, the question, I've done it with y'all, so somebody in this room has to know how to do it. Question number, where is it? The one with the numbers that were divisible. I know Sonia and I went over it. Question number 12 on the bottom of page 2. Y'all work on that. I'm gonna try to do this complicated question maybe.
Wait, the one where it's like, what is the sum of all 3 digits which are multiples of 14 but not 21?
Yep.
Oh boy.
Oh, I remember it now.
I think we worked on it, right?
Yeah, we did.
Yep. Do y'all feel okay with that one problem?
Which problem is it again? I can't.
Bottom of page 2. Number,
Oh, 12.
wait, no. Yes. Yes.
Does anybody have the answer?
Yeah.
What did you get?
23,926.
Yeah, that's what I got. Cool.
Anybody have any questions about that one? Um, okay, so lastly, I guess, let me try. Instead of giving you the answer to that one or talking about necessarily what the question is saying, I don't even want to give you the hints because I think it just makes you guys want to do the question more, if that makes sense. But in terms of laws of exponents, if you have something in a fraction, how else could I rewrite this?
2 to the power of negative x.
Yep. Everybody got that?
Yeah.
Okay, if I have how could I rewrite that?
The square of the, like this, it's not the square root, but like the,
Cube, isn't that cube root? No.
So then
Yeah.
you can rewrite this as the cubed root of 2.
times 2 to the power of n.
Yes? Everybody okay with that?
Yes.
Okay, when you have a how do I say this one? I'm trying to do this without giving away the question. You have let's walk through simplifying that. What's one thing we could simplify about this right away? There's a couple things. So
Could you rationalize the denominator?
we don't want to.
Okay.
How else could you rewrite the denominator though?
X to the power of 1/2,
Okay.
and then x to the power of negative 1/2.
Okay. And then there's one more step about this one now that it has a natural log. Do y'all know what it is?
No.
So basically your power becomes your coefficient.
Oh yeah. Oh yeah.
Yeah?
Algebra 2 memories. Mhm.
Ms. Thompson, I don't think that I've learned this, so can you explain to me what is that?
So it's called the laws of logs and the laws of exponents. On your formula sheet, you might have some of them. Might not. Yeah. Okay, so I'm gonna, on your formula sheet under topic number 1, under your sums, they have the exponents and logs. So one of the things, the way it's written on your formula sheet is it says a to the x is equal to b is the same thing as x is equal to log base a of b.
Yes.
What does that mean?
So
Oh,
basically this is just I'm just going through the laws really quickly. So basically if you this in terms of if I said 2 to the x, this part, the 2 is called your base, right?
Yeah.
Okay. So if you're going to take a log, my base comes here. It's log base something, meaning it's the inverse of raising something to a power.
Yeah.
So it's called log base of whatever base we're working in. And then the x comes in front. It's called the, my teacher called it the swoop. That's just what he called it. We had to memorize this. This is given to you. But also on your formula sheet, they give you all of these. They say log, oh my goodness, I can't write. Log of xy is the same thing as log of x plus log of y, which is just like your exponents. Remember?
Yeah.
Like we had, like multiplication is addition. So does anybody have a guess of what this would be?
Log x minus log y.
Yep. And then you have basically the one that I was just talking about. And then the last one is change of base, but you don't need that one yet for that problem in particular. So like knock, I like it's not really teaching them necessarily. Like the way I teach it to my students, I feel like, is to normally just walk them through a couple examples. It's this is a formula the same way that you learn Pythagorean's theorem. It just is. Like there are proofs for them, but it's just something that's been proven by someone a lot smarter than me. And then really quickly, the only other piece that I think might trip you guys up on that question maybe, if I have, let's say, when we solve problems like this normally, we just combine the like terms in our head, right? What would the first step be?
3x minus 9x, which would be negative 6x. And then...
Right. So we normally just say, okay, those are like terms. So we just move on with our lives. But technically what you're doing is called grouping. And so you're doing 3x minus 9x plus y plus 7 plus 2.
2.
So just remember that you can regroup in terms of variables. That's the only other thing in that question. But again, I'm not expecting you to do that question. I mean, you are more than welcome to try it, and I'd like you to try to write down what you can. But even if it's in the middle of the test, you find the questions you know how to do. Right?
So if we get it wrong, are we not going to be taken off?
I didn't say that.
Darn.
There are questions on here that are difficult. There are questions on here that I think are pretty dang easy for IB questions. If I give you and I tell you that it's arithmetic. And I want you to find the sum of the first 7 terms. Do y'all know how to do that?
Yeah, I think so.
I think you do too. I think you do too. I don't think it's bad. There are quite a few questions that are similar to ones on the packet. Some of the ones on here that are on the packet are even easier than the ones on the packet though. Like the one that I just had you guys practice about the numbers that are multiples of 14 but not 21. Like the one on the test that's like it is even easier. Like you only have to do the first part. Like you don't have to do the not part.
Okay.
I really think y'all will be okay. My intention is not for this test to kill your grades. I think y'all have seen that I don't let things kill your grades, especially when you're putting in the work, right? But
Yep.
if I can do nothing else in these 2 years, I just want that IB exam, not even necessarily to feel easy, but to feel like it wasn't that bad. Good?
Mm-hmm.
All right. I have time for one more question if anybody has one.
Before we have a question, I have a question. It's like, really, it's not dumb. It's not about math, but it also is. I need to turn my camera on to explain this.
Okay.
My calculator died, right?
Uh-huh.
And I don't have a charger. And so all I have for tomorrow is this calculator. So
You can use your email. Go to ti.com and I think there's a temporary trial for calculators.
so I can use that because like
Yes. But I do think you should probably what happened to your charger?
I don't know where it is, like because I charge it at school, so I think it's still in my locker at school.
Gotcha. Well, you know, it might be worth getting an extra one. Because I honestly don't know when they're gonna open up the school again.
Yeah.
So
Okay. So I can use TI
for now, yeah.
and not this.
And not that. I'll let you use TI. I'm not gonna let you just use your computer though, if that makes sense.
Okay.
Yeah.
Okay, cool. That's it.
Okay. Anybody last question, or do y'all just want to call it?
Are we just calling it?
Okay. So yeah, that's it. Bella, do you want to stay and talk, or do you want to wait till tomorrow?
Can we just wait till tomorrow? Because I'm
Yeah.
like really tired. So.
I feel that on a spiritual level.
So yeah, I don't know how well it would go.
Me neither. We also still need to talk about Thespian Society next year, apparently.
Okay.
I'm gonna be straight up with you. Not my priority right now, though.
Me either, but we can talk about it.
Sounds good. All right. I will see you all tomorrow in the afternoon. HL students, don't forget that you have HL before your test.
Oh, okay.
Yeah.
Wait, HL tomorrow morning?
No, during lunch.
Oh, right. It's Thursday. Okay.
Yep. So y'all have a project to work on. All right.
Okay.
Thank you, Ms. Thompson.
Bye,
Bye.
Miss.